Hello, everyone. I'm Arkadiusz Sinowczyk, and today I'm pleased to be able to talk to Dr. John D. Norton. Hello, Doctor.
Hi, Ark, if I can call you Ark.
Absolutely. John D. Norton is a professor in the Department of History and Philosophy of Science at the University of Pittsburgh. He is a distinguished philosopher of physics and philosopher of science in general, specializing in the history and philosophy of science, particularly in topics related to Einstein's theories of relativity, thermodynamics, and quantum theory, as well as the topic of scientific confirmation. As for the latter, he is known for his material theory of induction, an account of scientific confirmation that is an alternative to both skepticism and Bayesian confirmation theory. And actually, today, the main topic of our discussion is the material theory. And actually, yesterday, Dr. Norton's latest book on the topic, titled Large-Scale Structure of Inductive Inference, has been published. So, congratulations.
Thank you. Thank you. I'm pleased to see it finally published. It's been in draft for several years already.
Yes, and it's published in open access, as far as I know, in a digital form. So I will put a link to it in the video description, so you can get it for free. However, there is also an option to buy a printed version, so don't be scared away. Let's start with a very basic question, namely, what is induction and what is the whole problem with it?
Okay. I have a very broad definition of what inductive inference is, or what induction is. In the older literature, induction was just generalizing from particular cases. So some A's are B, and therefore all A's are B was a very standard definition. Excuse me, I've something in my throat now. I think that's better. I follow the tradition that I inherited from one of my heroes, Wes Salmon, goes back to Reichenbach, and that is that inductive inference is ampliative inference. This is any form of inference where the conclusions are stronger logically stronger than the premises. So it certainly includes the old idea of inductive inference. When I talk about inductive inference, I'm being very general. I follow the idea of relations of inductive support with the rise of probabilistic notions of an inductive inference. We sometimes abandon the idea that you infer from some premises to a conclusion. Very often you simply talk about a relation of strong support between, say, evidence and theory. That's very much a Bayesian way of thinking about things. We'll find, I think that goes back to at least to Carnap, and there's this slogan that there are no rules of detachment. You always have to keep the evidence present when you're considering the extent of support for a hypothesis. So inductive inference is ampliative inference. Any inference that whose conclusion logically goes beyond the premises, and also relations of inductive support, such as we see paradigmatically, but not exclusively with probabilistic relations of support.
Yes. So this account of induction includes also things like explanatory reasoning, trying to figure out explanations for, let's say, observed motions in the sky, or analogical reasoning. Okay, now let's move to what is the whole problem with induction, because the book is very much concerned with it.
The idea that induction and problem go together is venerable. Right? You can go back to an ancient tradition. I call that inductive anxiety, and it's well-founded, because the early notions of induction were simple enumerative induction, and that is, if you found some A's are B, you could then conclude that all A's are B. And people have known from the very beginning that that doesn't work. Right? For every case where you can say some A's are B, therefore all A's are B, you're going to find many, many more cases where some A's are B does not generalize to all A's are B. I assume everyone knows lots and lots of examples. So the idea that there's something problematic about inductive inference is absolutely well entrenched. Things changed in a very interesting way with Hume in the 18th century. Hume asked a stronger question. The idea was that somehow inductive inference can be powered by maybe a principle. Nature is uniform. We can presume that the future will resemble the past in some aspect, or looking to later writers, maybe there is a principle of induction that we can use to justify inductive inference. You argued, I think very persuasively, that you can't have any sort of principle like that that is itself justified. It's either a circularity, you try to get it to justify itself, which feels like cheating, or you trigger a hierarchy of inductive relations. This principle is justified by that, and so on, all the way up. Now, I'll indicate the oddity of this from the very beginning. This is one of the themes of my own thinking about inductive inference. The philosophers are quite in despair about inductive inference, but the scientists are not. They use it all the time, and everything seems to be going terrifically well. So C.D. Broad in the 1920s had this wonderful slogan, compressed down, it's this, that induction is the glory of science and the scandal of philosophy. Now, it shouldn't be that way. One of the things that we need to think about is where's the problem? For philosophers who are unable to find a justification of inductive inference, they would like to export the problem and say, well, the scientists have got to clean up their act then. I think that's a dramatic misdiagnosis of what's going on. The scientists are doing just fine. They have no need to repair their methods. The methods are working extremely well. The people who are in trouble are philosophers, because philosophers have been unable to give us a solid foundational account of how it is that science works so well. Of course, I have a view on the matter.
Yes, and both in your previous book on the topic, to a lesser degree, and in the new book of yours, you provide an answer to that problem. However, you also highlight that the material theory of induction, as you call your theory, is not just an answer to skeptical arguments, but is to be broadly understood as a theory of how science works. And so its value is much broader. So could you sum up the core claims of the material theory, especially as it appears in your latest book?
Yeah. Well, first I'll tell you what I think the real problem is with inductive inference when it's handled by philosophers. The real problem is that they have been searching for universal principles, universal schemas of some sort. The model that they use is the model of deductive inference. It's possible with deductive inference to have general schemas. A very simple one is, I think it's called conjunction. If your premise is A and B, right, you're then authorized to infer to A. And it simply doesn't matter what A and B might be. You're always authorized to infer from A and B to A. So people working in inductive inference, philosophers working in inductive inference, have tried to replicate that in some way in inductive inference. And if you look at the plethora, the vast array of different approaches to inductive inference, that fact alone is already a clear indication that something isn't working. If we keep changing our minds about exactly what the rules are that govern inductive inference, we can't seem to settle in on anything as the final answer. That's a pretty big warning sign that something's gone wrong. What I think has gone wrong is the basic idea that we should be modeling inductive inference on deductive inference. That is, that we should be looking for general schemas. I'll include in here what the Bayesian analysis gives us. It's the general schema they identify is the probability theory, the axioms that perhaps Kolmogorov wrote down. Choose your favorite axiom system. What I realized is that if you were to press scientists about how they're doing their inductive inferences, they wouldn't be reciting chapters in logic books. So one of the examples I've used repeatedly is Marie Curie, who has a tenth of a gram of radium chloride prepared for the very first time. I chose that example because when Marie Curie was working on this, a fine Polish scientist I'll mention. I won't try and pronounce the Polish name, if you will forgive me, Ark. When she was working on radium chloride, that 1/10 of a gram was the only sample that existed in any laboratory anywhere in the world. Yet she was able to infer the crystallographic properties of radium salts or radium chloride in general from that one sample. Now, you could say to her, if you could somehow travel back in time as a philosopher and say, but Madame Curie, surely that's a very risky thing to do. It's an enumerative induction based on one instance. This sample of radium chloride has such and such properties, therefore all do. You can't seriously think that's a good inference. My hunch is that she would just be incredulous. I have no idea what you're talking about. And instead, she would tell you about a lot of facts about about crystalline substances. Exhaustive work all the way through the 19th century had established that crystalline substances naturally fall into a small set of different families. And once you've identified a new sample of some novel crystalline substance as belonging to one of those families, you have a good prima facie case that all of the samples will belong to that family. There are more complications. There's polymorphism, dimorphism that can get in the way. That's what makes the inference risky and inductive. And so that's actually, from my perspective, a good thing. But the key thing is this: the justification that's coming for that inductive inference is not in a argument form, a general argument form. It's coming from a fact. Another example that may be useful, you mentioned analogical inference. For philosophers, analogical inference is an argument form. We have abstract schemes for, positive analogies and negative analogies, and we're supposed to be able to somehow determine when a positive analogy outweighs a negative analogy and when another analogy is neutral. And it's just proved impossible to get very clear on exactly how you do all of this. And every time you look at a new case, there's a chance you have to revise the general argument form. The odd thing about that is that this is not the way that scientists think about analogies. Analogies are just simply factual ladders. One of the chapters of my first book, Material Theory of Induction, looks at a number of examples. The liquid drop model is an example of the nucleus is an example of that. One that's actually rather close to my heart is the Reynolds analogy in fluid flow. My background in chemical engineering was one of the great ideas that we were promised. So if you now take that scientists reasoning analogically regard the basis of their inference to come from a fact, the particular fact that says this particular system resembles that particular system in such and such a way, and that is sufficient to carry over inferences, then you have another example of material inference. Right? They're not using a general argument form. The thing that warrants the inference is a fact. More examples possible. I don't want to leave out the Bayesians here. I think the Bayesians are wrong in assuming that the probability theory provides a universal template for all sorts of chancing reasoning. I don't think it does, but I do think it often works very well, and we know exactly when it's going to work very well. It works very well when there are facts in the background that authorize the use of probabilities. There are many cases of that, and I've searched out many cases where the facts aren't there, and an attempt to do probabilistic analysis produces just egregious fallacies.
The way you explained it was very interesting because you said that you were thinking about how scientists would answer the question of why are they justified in believing what they do, and instead of looking for some complicated formal schema or schemas, you're saying it's not working by formal schemas, it's working by facts. Facts power the inductive inference. And what's interesting in this is that actually Hume, in his writings on induction, provided a necessary requirement for a solution of his problem, namely that don't look for something that's accessible only to advanced philosophers. You have to give me something that's accessible to a daily reasoning person, because otherwise what everyone believes up to this point isn't justified at all. Let's now move briefly more to the topic of what's wrong with applying probability theory in general to inductive inference.
Well, the way I formulate this is as follows. You're authorized to use some mode of inductive inference in a domain if you can identify the facts in the background that authorize it. So this is the initial divergence between me and Bayesians. The Bayesian idea is that anytime there's some sort of uncertainty, anytime you're not sure about something, that uncertainty can be captured by the probability theory, right? So it's a default. I don't accept the default. I think if you want to use something like the probability calculus, you have a positive obligation to show in some background fact that it is the appropriate thing to do. Now, appropriate thing to use. Now, there are lots and lots of cases of this. Perhaps the easiest sorts of cases are when you get probabilities in some kind of a physical theory, statistical physics. The physics of the thermal systems is very heavily dependent on probabilistic analysis. Exactly how the probabilities get in there is an enduring topic of foundational work in philosophy of physics. But the idea that there's something physically going on that authorizes the probabilities are there. Quantum mechanics has, of course, introduced irreducible probabilities if you take a standard approach to quantum mechanics. In many broader areas, if, for example, we're doing something with large populations, you want to say that it is extremely unlikely that the DNA of this blood sample does not match the DNA of some other sample. What makes that a probabilistic inference is that you're assuming that the DNA sample has been randomly sampled out of the population. Right? You have to make some sort of assumption like that in order to get the probabilities in the first place. If you don't make that assumption of random sampling, then the entire analysis is suspect. And of course, the notion of random sampling is a probabilistic notion. It says that every individual has an equal probability of being chosen. But let me show you how you can get just egregious fallacies. This is what I call the inductive disjunctive fallacy. I've found very many cases of it, but this is one that's been in the popular eye for a long time now. There's this idea. Am I going on too long here, or should I give an example?
Feel free to go. Yeah.
Okay, that's okay. You'll find in many places in academic literature and in popular literature, and I guess even in YouTube videos now, people are taking seriously the idea that we, the world, everything we experience, is very probably a computer simulation. So we are lines of code, if you like, or lines of code being implemented in some computer somewhere. So how do they get this result? Well, it's an appalling accretion of fallacies, just one after another. I just want to identify the one that is pertinent to us here. By rather dubious argumentation, they arrive at the idea of a range of possibilities, right? It's possible that we're a computer simulation. It's possible that the world is really just the way we see it to be. And then they have this argument that there are very many more ways that we could be a computer simulation compared to the number of ways that we could be real. Okay, I'll accept that as a premise, all right? And in particular, we simply do not know which one of these we are. Now, I would say we have to stop there and say, well, we just don't know. I'm suspicious of the argumentation that got us to that point, but let's accept that as a starting point. How do you go further? Well, the only way to go further now is to assume, we don't know, so there's a chancy element here, there's an element of uncertainty. I'm going to represent that probabilistically. And so you take a probability measure and you spread it roughly uniformly over all the possibilities. It doesn't have to be exactly uniform. I'm not even sure how you would know that it's uniform or not, but assume it's just roughly uniform. Then the fact that there are vastly more ways of our world being a computer simulation than there are of it being real means that all the probability goes to the computer simulation. And so now we have a very profound result, right? The profound result is that very probably we are a computer simulation. I hope you can see from the way I've described this that there's no background fact that authorizes the use of probabilities. It's just a default. There's an uncertainty. Okay, let's use probabilities. Now, no scheme of inductive inference is benign, right? Every scheme of inductive inference augments what you know factually. So there has to be some kind of factual anchor for it. That's why I keep asking for there to be factual warrants for the inductive scheme you want to use. There is no one for this. And as a result, you commit an egregious inductive fallacy, right? The whole result is simply an inductive fallacy that should never have happened. And it's a direct result of the default idea that whenever there's an uncertainty, you can just use probabilities to represent it. Absolutely not. You're going to get into lots of trouble. I've analyzed lots of cases here. This doesn't often come up in real scientific applications, but I was rather pleased to discover that a thing known as the measure problem in inflationary cosmology suffers exactly from this difficulty as well. There's an uncertainty there. Okay, it's uncertain. We don't know. You should stop there, right? But they don't. They say, well, how can we represent this probabilistically? And they get into all sorts of contradictions because there are too many ways to do it. They don't fit together. And the answer is don't apply probabilities there. You have no warrant, no background fact authorizing it.
Yes. So while this may not be actually so prevalent in science, in philosophy we actually see various arguments that, like the brain in a vat argument, Descartes' demon, where there is some supposed possibility that we are being deceived. And so basically, from what I get, what you say in your book about Bayesian probability theory is that it's a formal schema, and what you will get out of it depends on what you will put into it. So if you put in garbage, you'll get garbage out. And whether you put garbage or non-garbage is something beyond the calculus of probability theory.
Yeah.
Yes, so applying probability theory to scientific reasoning is the main way people in philosophy of science approach induction. What about externalism as a way to solve the problem of induction? Externalism being the idea that you don't always have to have access to the things, the justifiers. You don't have to have access to a step-by-step proof that will basically establish a given claim or its probability.
Well, okay, we've now made quite a big jump. So far, everything I've been talking about was in the first book. I'm now happy to move to the second book, which concerns the large-scale structure of inductive inference. Do you mind if I just give a bit of a prologue before we talk about that particular?
Absolutely.
Yeah. So here's a very natural reaction. I say that every inductive inference is warranted by a fact. By fact, I mean it in a strict sense. It is a truth, a contingent truth of the world. That's the sort of thing that does the warranting. So if we want to reason well inductively, right, we have to have in our possession knowledge of these facts to guide us. But how do we come to know those facts? Well, they're contingent, right? And as a result, there have to be more inductive inferences to let us know which are the facts. We'll never be absolutely certain. Inductive inferences is always fallible, but we can certainly get so close to certainty that that we can proceed practically without too much concern. So that's the topic of the second book. How do all of these pieces fit together? So every time you would look at a science, there's inductive evidence for this proposition and for that proposition, and for that proposition, and they're all warranted by facts, which in turn have inductive support for them. At least if it's a mature science, then you cannot point to any particular proposition in the science that is not amenable to inductive support. That's how a mature science can be identified. and that's where the rigidity and solidity of the science comes from. Okay, so we now look like we're running into trouble, something that looks like Hume's problem. So I should identify why I think Hume's problem is dissolved by the material theory of induction. This is in chapter 6 of the large-scale structure book. The formulations of Hume's problem of induction, Hume's original formulation and later formulations, all depend on some universally applicable principle or schema. Right. The simplest one is that things will always continue to be the way they have been. You can project present regularities into the future, and then the idea is you can apply that rule to the rule itself, and of course you immediately get a sense, no, that's cheating, right? That there's an arbitrariness involved there, or you end up with this infinite hierarchy, which was introduced by Popper, by the way, in his work of the 1930s, that regress form of the argument. So the material theory of induction doesn't have any of those rules. Right? There are no universal rules of inductive inference. There are no universal schema that have to be justified by themselves or by other universal schemas. So if you want to sit down and simply take the text of standard statements of the problem of induction and try and realize them within the context of the material theory of induction, you can't do it because the basic thing you want to talk about isn't there. So, that I claim is essentially the end of it. It's a dissolution of the problem of induction. These things are, this is a standard way the problems get dissolved. So, for the longest time, Newton was very bothered, by the idea of action at a distance. He thought it was scientifically incompetent for anyone to think that something here could, without any intervenient medium, act on something else somewhere else. So, of course, action at a distance was routinely taken to be the standard idea behind Newton's theory of gravity. It gets solved when people realize, hey, wait a minute, in the 19th century, it's all field theories. There are no unmediated actions at a distance. The problem's dissolved just by saying the thing that causes the trouble isn't there. And I'm just doing that, right? It's how an atheist solves the problem of evil. There isn't a benevolent God that we have to explain why the benevolent God allows all these horrible things to happen. Okay, that's the dissolution. Anyone who's been in this literature knows that there's an automatic comeback, and the automatic comeback is, okay, fine. But every time someone says they've solved the problem of induction, it pops up somewhere else. It's like the bump in the carpet. You've laid down the carpet, it's too big for the room, and you press the bump down here, and the bump pops up somewhere else. Right. And so the worry is that the same sort of mechanism will reappear. One of them is that we have this massively entangled set of relations of inductive support. The simplest idea is that maybe you start out with one inductive inference. It's warranted by some background fact. That background fact has to be a fact of some considerable scope to warrant the inductive inference, presumably in some sense of greater generality than the things that you're dealing with. So what then warrants that fact? Well, again, you'll have another inductive inference with a warranting fact that is still more general, and you produce this hierarchy of ever more general warranting facts, and it's an infinite regress that is going to end, that can never end, and just leads to a collapse of the system. Well, if you're just abstract philosopher thinking about these things, that sounds fine. But if you do what I always do and go and have a look at the sciences themselves, you discover that the kind of hierarchy that we're just talking about does not appear in the sciences. What happens is that the relations of inductive support cross over one another in all sorts of massively tangled ways. So something over here can support something over there, and something over there can support something over here, and you simply cannot identify this infinite regress. I know some philosophers have tried to argue that the infinite regress is there, and they can only do it by inventing fables that I don't see in the science. The book has many, many examples of the kind of crossing over of support. Here's a very simple one. That'll give you a sense of how it works. We like to date artifacts in archaeology by using two different sorts of methods. One is historical. That is, if we can trace a provenance of some archaeological artifact back through the centuries, we can then compute exactly, when it happened, right, or when the thing was when the thing was formed. The Shroud of Turin is an example of that. People, it popped up at a particular time. There are no earlier records of it, and we have some evidence of the kind of techniques that we used to make it. So we have a kind of historical dating for it. But then there's carbon dating as well. Right? You can look at the levels of carbon-14 as they decay away in an artifact, and simply from the physics of radioactive decay, you can determine how long the artifact has been has held its carbon trapped. It's a little bit more complicated than that, but that's enough. So the idea is, well, what supports what? And the answer is they both support each other. Right? We routinely use the historical dating in order to establish the correctness of the carbon dating, and we also use the carbon dating now to establish the correctness of the historical dating. So they're just massive crossings over all the time. That's incredibly simple, but you get a sense of how crossing over can happen. The real relations of support are vastly more complicated. I've collected many, many examples of them, and some of them are a lot of fun when you see how things cross over. All right. So that then answers the concern that there's an infinite regress in warranting facts. No, there isn't. But it then raises the second concern. If you then trace relations of inductive support through the entirety of science, you can end up back where you started, and that is a circularity. And at this point, there's this cry of pain. The circularity, it's all over. No, it's not. I know we were intimidated by Russell's vicious circle principle at the beginning of the 20th century. We're supposed to gasp in horror whenever we see a circularity. We shouldn't. Clearly, some circularities are bad. Russell's paradox and the set of all sets, etc. The idea of some sort of self-reference, the liar paradox. Yes, those circularities are terrible. There are many more circularities that are not, and I've collected lots and lots of examples of them. Just off the top of my head, one of them is Maxwell's equations for electrodynamics. The free field equations are 4 equations in 2 quantities: the electric field strength and the magnetic field strength. And each set of equations talks about the other set of equations, right? And there's a circularity there, and it's completely benign. Electrodynamics works perfectly well. So the moral that I draw from that is the following. It's the same sort of moral as you get with the material theory of induction. If you're going to assert that a circularity is harmful, you have to positively make the case as to what the problem is. Let me just pause here for a second. So what are the sorts of problems that circularities can produce? Well, one of them is an internal contradiction. That's the liar paradox. That isn't happening. Another possibility is that you get an underdetermination. The idea of a rule of induction validating itself, actually, we're uncomfortable with it. But why are we uncomfortable? We're uncomfortable because there's an arbitrariness there. We have a well-justified sense that we could cook up a different anti-inductive rule of induction that is also self-justifying, and we can. There are nice examples of that in the literature. So here are 2 sorts of worries. One is contradiction. One is underdetermination. Now, both of these things actually happen in these relations of support. If you have relations of support that produce contradictions, that isn't the end of the science. That's simply a challenge to the scientist to sort out the contradiction. And we have many examples of that. The most famous would be the old quantum theory. For some 20 to 25 years, we had theories of quantum mechanics that were internally contradictory. There was all sorts of relations going on that didn't fit together, and the business was to try and sort all this out so we could get rid of them. Or on the other side of things, you might have a case where the evidence is simply not strong enough to pin down any particular result, and that's once again just a challenge to do more science and and get a definite result. Science thrives at that. I gave the example of that sort of other determination in 19th century chemistry. After Dalton had opted for an atomic theory of elements, he was unable to determine what we would now call the molecular formula for water. Was it HO or H2O or HO2? And he was caught in a kind of circularity that he couldn't break, that enabled him to have any one of those formulae, and he couldn't pick which was the right one. It took something like half a century before the definitive result came through Canizzaro's work at the Karlsruhe conference, where he determined what the appropriate formula was for water. So I just don't think that either of those problems come up in the material theory of induction, and I'm comfortable in saying that the material theory has resolved the problem of induction. I fully expect people to dispute that, and if I'm right, whoopee, we've solved the major problem. If I'm wrong, what's the damage? Well, we just discovered that the material theory of induction is like every other theory of induction. It doesn't answer the problem of induction. Puts me in good company with everybody else. I don't think that's the case, but that's the worst that we would infer from it. So just to say a bit more about the book that you noted has just been published yesterday. The major burden of the book is to establish the results that I've just described, in particular to illustrate copiously the non-hierarchical character of inductive support, that the circularities are benign, and to give all sorts of illustrations of the way this works and what else we can infer from that.
With that extensive presentation, my entire structure that I planned has been destroyed.
Oh, sorry.
Though it's a nice accident that some formal schema again doesn't work when faced with reality.
There's a major difference between what I'm doing and the question you're asking. I'm interested in relations of inductive support as they appear in science. So I'm presuming that we have arrived at a presentation of experience such that it can be represented propositionally. And then I'm asking, what do the various propositions enable us to do? And I'm asking for explicit relations of support that can be identified by the scientist. So if some scientist asks another scientist, well, what evidence do we have for the Big Bang in cosmology? Right? Then that scientist can then start producing relations of inductive support and the facts that warrant them. Now, in epistemology, we move back one step from that. We start asking, the major terms in what I've just described are propositions and relations between them, relations of inductive support between them. In epistemology, we go back one step, and the major terms that we consider are states of mind, and inferences in this literature are habits of mind or mental practices that we have this thought, and that leads our minds to move on to that thought. Right? Now that's the way epistemology works. There's been a long-standing conflation of the two. If you read here, you can see him bouncing backwards and forwards between the two different approaches. I think we need to separate them. And so the question of externalism then lives within the earlier case, right? Is it possible that the mind can somehow proceed correctly from this thought to that thought that is logically stronger for reasons that the person cannot articulate, right? You're more of an epistemologist than I am, so you can tell me what those sorts of reasons are, but a very obvious one will be something evolutionary, right? We've somehow, evolved to make that particular inference that, that something that smells awful to us is dangerous to eat. right? Well, if you're not able to make that inference, you mightn't live very long. The question that I would ask is, in the material theory of induction, if we take that habit of mind and formulate it in propositional terms, do we get a good inductive inference or not? Now, what is the warranting effect? So externalism, I don't see helps with my problem, and I'm wondering now we come to some things I actually wanted to talk to you about. I think, one of the things I want to emphasize with what I've done with the material theory of induction, it is really a very different starting point, right? I don't think I'm the very first person to try some sort of material account like this, but I think what I've done is the most elaborate attempt to try and to get it all to work. But in principle, being responsible for inductive inferences in the totality of science, when you recognize how complicated it is already an overwhelming task. I don't think I've said everything that can be said or should be said. I think there are many open problems. One of them that I think is very interesting is what happens when we start to introduce these ideas back into epistemology and the sorts of issues that you're talking about. Externalism says that external factors can lead us, in effect, to infer well, right? We do infer well when we infer from the bad smell to the fact that it's dangerous to eat, right? What makes it a good inference? It's the same problem that I'm now working on, right? But now it's being brought back into a realm where the relata are not propositions, but they are states of mind, and the processes are not identifiable relations between propositions, such as probabilities, but they are something about mental operations. So the question that I don't have the expertise to answer is what happens if we go back and we introduce material ideas of inductive inference within the epistemology itself. I did some fairly deep reading into coherentist epistemology because there was initially a supposition that maybe coherentist epistemology, coherentist theories of justification in epistemology are the sort of thing that I'm doing, but now in the at the level of propositions. I was initially hopeful that this would be helpful to me because, I have lots of problems to figure out. Are these circularities benign? Are they not benign? Oh, wait, here are coherentists who are arguing, yes, they're perfectly benign. And so I went back to try and figure out what's going on. And there are just too many differences between coherentist epistemology and what I'm doing. And one of them is a very uncertain and even naive notion of what are good inductive inferences. I think this is a problem all the way through epistemology. Epistemologists don't have a good grasp on inductive inference because it's really complicated and really hard when you see it working well in science. I saw that at times the coherentists were using probabilistic notions. They were being used rather uncritically. They were just assuming that by default you can introduce probabilities and everything's fine because they have the charming but naive idea that somebody somewhere else has figured all this out and that makes it fine. If you read my stuff, you'll get a very strong sense that no, someone else hasn't figured all this out. They've just written a lot. All right. Does that answer the externalist question? Probably in more detail than you wanted, but...
Yeah, it definitely answers this and other questions to which we may also later move. Maybe with that rigorous argument against the material theory of induction, don't you think there are many unquestioned assumptions in that argument against the theory? For example, the argument tries to go back through the whole hierarchy of beliefs or propositions back to the beginning stage, where, at least as you frame it, the material theory of induction from the beginning was aimed to explain a very highest levels of knowledge. So you have dealt with Einstein's theory, with quantum theory. You've dealt a little bit with Newton, but you haven't dealt with, let's say, daily inductive inference. So on the one hand, the objection seems misplaced because that's not what the theory was supposed to account for. And actually, if you are trying to do purely logic, questions of the basic level, which would be the perceptual level, are questions of epistemology. So the objection from one perspective seems very misplaced. And on the other hand, I've read some critiques like that of Solber, where they claim that to infer materially, you would have to do it from some more general material fact. I don't know where that assumption that it has to be more general comes from. Why can't it be less general or whatever?
Yeah.
Or
I think I get it. There's the getting started worry, right? There's often given as a kind of parable. A primitive atom, I think this goes back to Hume, even the atom. A primitive atom who knows nothing steps out of his cave for the first time and tries to make inferences, right? So he's seen the sun rise once or twice. On what basis can he now infer that the sun will always continue to rise? Now, the argument is that in order to infer inductively well from I've seen a few sunrises to the sun will always rise, the primitive atom needs some sort of general principle that's strong enough such that when it is applied to the datum of a small number of sunrises, it then authorizes inference to all cases. So there has to be something of universal grasp within that background fact. Okay, and that's the challenge. Tom Kelly articulated this very clearly in a PSA symposium that we had in 2008, so you can see it there. I have two things to say about that. The first thing I want to say is, please don't take the example of Adam seriously. Right? This is historical fiction. These are anthropological fables. There never was an Adam who stepped out of the cave and asked himself, okay, I've seen the sunrise a few times. How can I now inductively infer that it will always rise? We have to, we can't base our examples on fables. This is why you'll see all the way through both books, I have real examples, because I'm responsible to real science. Okay. Now, having said that, I can then, right, so as long as we remember it's a fable, I'll keep going with the fable just because it's easy. In reality, what would happen is that if we're at a point where an atom has enough cognitive capacity to even ask the question, there's a lot more going on in Adam's head, right? Presumably, there are all sorts of mythologies in his head. He's probably got some idea about a hopefully benevolent creator, and maybe he has the idea that the benevolent creator wishes well on Adam, and the sun rising is a very important thing to Adam's well-being, because it's only when the sun rises that he can go out into the world and do simple things like foraging for food or chasing down prey or however else he's going to survive. But on the presumption that there is a benevolent creator who's looking out for him, he can infer that the sun will continue to rise because the deity wants it to be so. Okay, complete fable, complete fiction, but the basic structure is the thing to look for. What Adam has done is to, in our modern language, posit a hypothesis that has enough logical strength to warrant his inference. Now, that's only the first step. He can now make the inference from some days the sun rise to all days the sun will rise. He is now in possession, as it were, of a universal fact. The sun will always rise, right? And he now has something general that he can continue to use in other inferences. But he's incurred a debt. It's an inductive debt. He has to now go back and show that warranting hypothesis, can be supported independently by other evidence. And it's only when he's successfully done that, right? That he can say he has inferred well, right? So that's a critical step. So it can fail. Here's an example of I would say a notable failure. In the middle of the 20th century, steady state cosmologists were taking as a datum the expansion of the galaxies, right? And they wanted to then know what is the long-term fate and the long-term past origin of the universe. And so they hypothesized the perfect cosmological principle, which says that the universe, in its gross aspects and in its rough, larger scale aspects, has been the same for all time. And if you assume that, you arrive at a steady state cosmology, which says the universe is always roughly going to look like this. And because the galaxies are expanding, right, matter is diluting unless something fills in the gaps. And so they posit continuous creation. They have evidence for continuous creation. But the key thing is they've made a hypothesis, the perfect cosmological principle hypothesis. They could never get evidence for that. And as a result, their inductive inference failed. What do examples of success look like? One extended example is how Dalton's problem of the correct molecular formulae for various substances was solved. If you simply take the data on gases and crystalline substances and try and infer generally from them, you need to have warranting facts that are of sufficient generality to get you there. And one of the ones that was used very extensively by Cannizzaro is the Avogadro hypothesis, equal volumes of gases under the same conditions of temperature and pressure contain the same number of molecules. We learn in our high school chemistry classes to recite this without thinking. But it was the critical hypothesis that Cannizzaro needed in order to complete his project. And he had to come back and get evidence for it. And he did. He introduced other, the literature introduced other hypotheses. The law of Dulong-Petit the specific heats was an example of that. You can get these crossings over support. So you get for Avogadro's hypothesis support from over here, and you get for the hypothesis of Dulong-Petit, you get support from over there. It all crosses over. One of the most interesting things for me was that there was an interface between chemistry and physics in the 19th century. So Cannizzaro and people who were working in that tradition were very keen to get as much independent support as they could for Avogadro's hypothesis. At the same time as they were doing their work, Maxwell, Clausius, and eventually Boltzmann were working on the kinetic theory of gases. That is, that they model gases as consisting of very many Newtonian particles bouncing around in elastic collisions. And one of the results that came out of that was the equipartition theorem. It's one of the foundational results in classical and statistical mechanics. And that equipartition theorem justifies Avogadro's hypothesis. You can go straight from the equipartition theorem to Avogadro's hypothesis. The chemists are delighted. Their hypothesis has found evidential support from the best new work of the physicist. Not how the physicists saw it. They switched things around. They recognized that this kinetic molecular theory was a highly speculative theory, and they were desperate to get good evidence for it. And where can that evidence come from? Well, they noticed that if you start with Avogadro's hypothesis, you get wonderful support for the equipartition theorem. Right? And so there was this spectacular crossing over, each saying the other's work supports that. So there you see it all you see the big ideas all in one nice example. How does inductive inference get started so it can have a general purchase? You need to make hypotheses of sufficient generality to do the work. You need to be very careful in the hypotheses you make, because you're going to have to come back and find inductive support for them, or else your inductive inference has failed. And they succeeded in doing that. And the inductive support was not this hierarchical thing where you needed a still more general warranting fact to justify the Avogadro hypothesis, something still more general to justify that, and so on and so on. No, you just enter into this massively entangled set of relations of support, and it all falls out from there.
Yes. So when you are speaking of hypothesis, do you mean conjectures without absolutely no evidence in their favor, or do you simply mean they have some evidence but not much? One of the fragments that prompted this question was that, quote, "But we can sometimes determine which propositions are plausible candidates for the facts that would warrant the inductive inference sought." So is there positive evidence at all or not for the hypothesis in it?
For something to play the role of the hypothesis here, you would be looking for something that maybe has no support at all, or maybe something that has a little bit of support. So, if it is well supported and fully supported, it wouldn't count as a hypothesis. It's just a result that you're using. So at this point, it's an arbitrary stipulation as to how we're going to use the word hypothesis. And I'm just stipulating that this is how I'm going to use it. It's when we introduce, for purposes of further inference, a warranting fact that does not itself have sufficiently secure inductive support. I'll distinguish it, by the way. This is not hypothetico-deductive confirmation. Right? Hypothetico-deductive confirmation works in a different way. What you do is you make a hypothesis, you look at its consequences, and if those consequences are verified, then you say the hypothesis has inductive support. That's not what I'm doing, and I'm very consciously not doing that because this is a very troubled form of inductive inference. The difficulty is that we can get too many hypotheses that are going to entail the successful evidence, and it leaves us with a terrible problem of trying to decide who gets the credit, right, for the successful prediction. That's always been a long-standing problem. I did a survey 20 years ago of different accounts in inductive inference, and a tremendous amount of effort has gone into trying to figure out how to get around that problem. And the general way it's done, this is a tangent about hypothetical inductive confirmation, but I'll finish it now that I've started. The trick is always to introduce extra assumptions. So the hypothesis needs to do more than just entail the evidence. It has to explain it, and then now you have an obligation to figure out what the notion of explanation is that's going to do the work, or it has to be beautifully simple. Another one, or it has to represent some kind of a severe test, but then you have to set up a framework, what counts as a severe test, and so on and so on. Right.
Going back a little bit to issue of self-supporting structures, how those structures will relate to experience?
Yeah. This is one of the claims that at first seems a little shocking, right? But actually isn't. Remember, the material theory of induction is a quite imperialistic theory. I say that's all there is to inductive inference. Everybody's account of inductive inference, insofar as it can be made to work, has to fit into the material theory. If you want to use probabilistic modes of inductive inference, fine, as long as you can show me the background fact that warrants it. If you want to use analogical inference, fine, but show me the background facts that warrant it. So now I then have to explain the following. I also think that what characterizes a mature science is that all of its propositions are well supported by evidence in one form or another. And we have numerous examples of sciences that look exactly like that. They are incredibly rigid, right? You can't change a little bit without bringing down the whole thing. Here I want to change, Quine's famous metaphor. Quine has this metaphor of all of the propositions in some sort of a web, and there are these elastic ropes connecting them, so you can go to some place and adjust something, and so you move it around a bit, and so everything elastically adjusts all the way through. I don't know what he's talking about, because that doesn't happen in science. In a mature science, those ropes are not elastic, they're more like steel cables. And if you try and move something, what happens is this cable snaps and that cable snaps, and the breaks propagate all the way through, and the whole structure collapses. So what am I thinking of? Here's an example that's maybe familiar to many of you. Darwin's theory of evolution has routinely been challenged for the longest time, ever, under theistic motivations. Right, and so the idea is that the species did not evolve, and so creationists intelligent design people try to come up with an account of how the species arrived at that doesn't use the evolutionary theory. So they're trying to poke holes in the evolutionary theory. But the trouble is, every time they poke a hole, they break some other piece of science. For example, they don't like the dating of artifacts. Darwin's theory needs a long past of many millions of years. The special occasions want a very short past, right? They want only I don't know 6,000 years or something. I don't know exactly what the number is. So they have to impugn the way that ancient artifacts have been dated. So carbon dating is an example of that. But radiographic methods for dating rocks go back far longer. So they have to impugn those methods. But what they're now doing is they're impugning chemistry, right? Because this is just radiochemistry. This is not biology anymore. This is radiochemistry. So, the attempt to break evolutionary theory in biology leads to the breaking of radiochemistry. It also leads to the breaking of cosmology. We have all sorts of observations of the recession of the galaxies, the measurements of the cosmic background radiation. All of that belongs into a well-supported theory of Big Bang cosmology that puts the beginning of it all back to 14 billion years in the past. Well, they've got to do away with that as well. So go back to the beginning. They wanted to break one little piece of science, but the ripples go all the way through. They have to end up denying vast amounts of science. Okay. So then to go back to your question, self-supporting structure. So how is it possible that all of this comes out of the material theory of induction? It's a version of that earlier problem of how do we ever get inductive inference started. The evidence that we can collect in our laboratories and in observations will always be finite. They say finite many sentences that we can write down in our scientific journals and in our scientific textbooks, right? But the results of the science that's supported by it are universal. They have infinite scope in all sorts of ways. How is it possible for this to happen? Well, I've already given you the example. Lots and lots of relations of inductive support crossing over in all sorts of ways, and it's erected by positing of hypotheses that eventually get supported. Now, the thing that I worried about in all of that seems fine, but the thing that worried me was this possibility. Might it be that you and I can start out with the same body of evidence, right? Perhaps even the totality of the evidence of all science, and I produced one science, and you produce another science, right? Now that would be a bad thing. So I thought a lot about this. This was really something that worried me a lot. It would, of course, be a very serious problem for the material theory of induction. So I did what I always do when this happens. I'm saying, but this doesn't happen in actual science. There's only one periodic table of the elements. The chemists did all this work in the 19th century, and it's hydrogen, helium, lithium, beryllium, boron, et cetera, all the way through. And that's it. That's the only way you can do chemistry. They don't say, you can have different tables of the elements and they're all different. No, there's only one way to do it. And this is the same across the board. The scientists always come up with, unique systems. And the assertion that there's no other possibility, right? That's what the biologists argue in response to the creationists. I've been looking, if you want another example of this sort of dynamic, look at the arguments about climate change. The IPCC, the people who are collecting all the evidence here, are just saying, look, there's no, human action is causing climate warming, and there's no other possibility. Right? So how are they getting this? Well, when I looked at the examples, what I found is the following dynamic. For there to be an alternative system, a different system, if it is properly different, there has to be some disagreement over a matter of fact, right? And if there's no disagreement over a matter of observable fact, then you really have to wonder if they are different theories at all. They aren't connecting in some way. So you have to say something in the world is different. But that's already a beginning that is telling you that a test is possible, right? If we have a genuinely different theory. And it's just, and if we have two theories that are that are competing to see which is the right one for this body of evidence, right? Then, then it's going to be a matter of further investigation to figure out which is the appropriate one. All right. So then there's more. Then when I started to look at this in greater detail, I began to realize there's a kind of instability in this. So we have two theories that are both competing. They make different predictions about what we're going to find out there in the world. The theory that gets it right then can use the fact of this fitting with their system to provide evidential support for their system, while it correspondingly weakens the opponent's system, right? The other system. But now remember, there's a slogan early on in the material theory of induction: you cannot infer until you know something, and to infer better, you need to know more. In other words, the more grasp you have of the facts, the more you know, the more you can infer inductively. And that's what's happening here. You have this instability between two theories. One has a success where the other has a failure. And so the successful theory now is strengthened in the grasp of facts of the world. And as a result, it can infer better to the detriment of the other theory. And you have this instability that grows, and you end up with one theory rising as the unique theory. I like doing little excursions in history of science. So I thought a neat example was dowsing. Dowsing arose in the 16th century as a technique for, not for finding water originally, but for finding minerals underground. It was kind of plausible at the time because, there were electric and magnetic effects that were being discovered. There were magnetic minerals that would affect iron and so on. And so it seemed plausible if you're looking for minerals that they might affect other things. And so hazel twigs, right, maybe they would be affected by the particular ores that were underground. So maybe, just as you could use iron to find magnets that were in the ground, maybe you could use these twigs to find these other ores. So it was, it wasn't obviously a silly hypothesis. There was a large community of dowsers who arose, and you could hire them to come and find ores for you, and that profession continued. So there's been this long-standing debate going back to the 16th century over the dowsers and the critics of dowsing, and you can see as one success after another for the critics was depleting the inductive resources of the dowsers until there were a lot of skepticism, but by the beginning of the 20th century, dowsing was really reduced to some sort of a crank science. The dowsers were reduced to assuming that some psychic phenomena, some mysterious psychic phenomena was responsible for the success of dowsing. Now, they're following a methodology that I've described. They want to infer to the success of dowsing's ability at this point now to find water underground. And so they need some sort of hypothesis to warrant the inference from, Bill went out yesterday and found water, therefore there's a general process of successful water finding that can be undertaken here. And so they go to the very, for us, dubious hypothesis of some kind of psychic action being involved. And of course, they can get no evidence for that, so it really just collapses. All right. We're doing well.
Absolutely. Let me know if the thing is going too long for you or it's okay.
I'm happy to talk about this. This stuff's been my life for a couple of years. So, more than a couple of years, many years.
Another thing that I wanted to discuss with you is actually I already sent you over the email, but I have to expand it. I even wrote a long version of my question because I'm better at explaining it on paper than in talking. So I'll have to take 2 minutes basically to talk alone. What do you mean by saying that inductive inferences are warranted by facts? There might be a worry that the theory is too much empty in terms of its semantics. Basically, the reasoning is as follows. The inductive skeptic begins by taking induction as the standard, then claims that the connection between the premises and the conclusion in induction is not immediate and therefore needs some schema that would serve as a bridge and make it deductive. Your theory attempts to bridge the supposed gap between the premises and the conclusion by invoking various statements that could be paraphrased as inductive inferences are warranted by facts, not by formal schema, or the support is direct without mediation of rules. But what does it all mean? If I were an inductive skeptic listening to your views, I might respond by asking, what do you mean by facts supporting inductive conclusions directly? I can't make sense of deductive support, but I simply don't know what you are referring to by material support and the various descriptions of it. I also say that inductive inferences are justified by some statements of fact, but without rules, all I see is us moving from some premises to an inductive conclusion and having some feeling of truth. I don't see any direct inference. The inductive skeptic, to sum up, takes for granted the notion of deductive support, but when faced with inductive support, he simply can't make sense of it. The problem, I think, is amplified if we try to avoid speaking of mental phenomena, separating logic from epistemology. It is easy to see how mind-independent relations of support in deduction can work. It's simply a matter of some semantic entailment. But some things simply entail another. But how would that look in induction? So that's in essence my very, very long question. I'm very curious of any kind of your answer or comment to this.
It's a great question. I really like it. I said early on that I think there's a lot more work to be done. And the very short answer is that I think this is one place where there's a tremendous amount of work to be done. I hope you'll do it, in fact, because I think there's a problem to be solved. I want to lay out some parameters for how I would like to see a solution come about. What I don't want to see is that the solution is going to depend upon bringing in some, universal rule of some sort, right? The reason I don't want to see that is because every time I run into a universal rule in the context of inductive inference, they all break. None of them work. It typically tends to be a last desperate measure to make something work. And you posit the general rule and you say they're done. And then someone's going to come along, and it's so easy to poke holes in general rules. The method I use is, I think, quite explicit. Anyone who has a general rule of some particular sort, I think about the rule, and then I start imagining worlds in which that rule would fail. Right. So in the case of the Bayesians, I've cooked up all sorts of weird physical systems in which there are indeterminacies where you would not be authorized to probabilities. All right, so that's the parameters around which I'd like to see a solution. The next thing I want to say is I don't think the solution is going to be easy. The reason is that inductive inference is different in principle in each domain that you go to. So there isn't a kind of a unifying theme that makes all of it work. And so whatever it is that's enabling facts to warrant, right, is going to be different as you move from case to case. And that's going to make it tremendously difficult to come up with a general theory of what's going on here. Okay, so that was one sort of answer. I'm going to give you a second sort of answer now, right? So I think it's a terrific question. I've worried about it. I've never been happy that I have a definitive answer to it. It might be that I'm demanding too much, right? I don't want to see general rules. I don't want to see them because they always fail, and because I think the actual practice of inductive inference is varied enough from case to case, that it's hard to say. Sometimes the warranting fact has the word generally in it, and the word generally looks like it's one sense, but it's not. It means something different in every case where it's used. Okay. Now let me tell you what my best effort has been. This has been my best effort to answer it, and I don't know if this will. Well, I expect it won't make you happy because you've already seen it. First, I don't see that there's a foundational issue in a fact warranting an inference. We're very familiar with this in deductive inference. So take what's it called? The syllogism: if A then B, A therefore B. Right? If the clouds look threatening and dark, then it will rain shortly. The clouds look threatening and dark, therefore it will rain shortly. Now, what's authorizing the inference from the clouds look dark and threatening to it will rain shortly is the if-then statement. It's a very particular statement. It says if, you got these ominous clouds above you, then it's going to rain shortly. And we have no problem identifying that fact as authorizing. The if-then statement asserts a factual connection between a present state and a future state. Right. So I don't see that there's a problem of principle in getting a fact for authorizing induction. You use the standard philosopher's locution of I don't understand. The easiest answer is, oh, that's an interesting statement about your mental state, right? Now what? So you don't understand. You probably don't understand renormalization in quantum field theory. I also had trouble understanding renormalization in quantum field theory. That doesn't mean there's anything wrong with it. Okay, so right. So we need a positive argument for why a fact can't authorize. Now the next thing is that. So this is the first thing. I think facts can authorize. Now the second thing is how does deductive logic work? In my view, deductive logic works because of the meaning of the connectives. Deductive logics, in my view, are actually rather limited because they can only be a logic of the particular term that you happen to introduce. So sentential logic just has not, and or, and it's just a theory of not, and or, which is frankly rather too weak to do much of anything with. Or you go to first order predicate logic, and then you've added in quantifiers, existential quantifiers, and universal quantifiers. That's a bit better, but it's still never enough to do the really fancy stuff. What makes it work is the meaning of the terms. So if someone makes the inference A and B, therefore A, right? What authorizes that is the meaning of the word and. If someone says A and B, wait a minute, I don't see how A is, authorized to be inferred from A and B. You would really say to them, I don't think you understand what and means. And means that you can do that. Right? It's one of the consequences of the meaning of and. I want the same thing for warranting facts. So Marie Curie has, generally, this is what I identified as Huys's principle in 19th century crystallography. Huys's principle says generally, all samples of a crystalline substance belong to the same crystalline family. Right now, the generally there is telling you that in most cases it's going to work like that, right? But there might be problems, and dimorphism, polymorphisms are the problems. Now, whatever the sense of that generally is, that's doing the analogous work of the and in a deductive inference. It has a somewhat uncertain meaning. It's not a probabilistic meaning, right? Take, for example, to get a clear sense of that, generally metals conduct electricity, right? Generally elemental metals conduct electricity. Now that's true, but there are only a finite number of elementary of metals that are elements. So trying to give a probabilistic analysis of that is really, it's really not going to work. But now go to another case. If I toss a coin 10 times, then generally it won't be all heads. Now we can make a lot more sense of that generally, and we can cash it out probabilistically. Right? And so as you move from domain to domain to domain, you will find locutions that can be used to justify an inductive inference, but they're going to have a different meaning in every particular case. And sometimes they're going to be a little bit vague, right? And that's worried me a lot. My default answer has been, yep, inductive inferences using that warranting fact are vaguer than we would like, but that's the science, and we can't do anything. We're not going to do better than the scientists who are struggling with trying to, So there's the, so in sum, contingent facts warrant in virtue of the meaning of the words, right? The meaning of the words is going to vary dramatically from place to place, and sometimes their meaning is going to be vaguer than we would like. Now, that's the best I can come up with. I would be very pleased if you come up with a better account. In writing the book, you can see the various chapters have, result from me sitting down and thinking, oh, wait a minute, there's a circularity here. How bad is this? Should I abandon the theory? No, let's have a look more closely at it. Oh, wait, is it possible that we can get multiple theories supported equally well by the same evidence? Let's think about it. And I could solve those. This one I'd like to have, I'd like to do better with. And I'm looking at you. You're going to do it.
Your answer definitely makes me very happy, because I already have my BA thesis about it, and so I want to make a paper out of it. And so the way you structure how this should be framed is also definitely making me happy.
Good.
Good. To share maybe a little tidbit to my viewers, my basic observation is that it's not only the problem. Yes, the problem with Hume's argument is that he says you have to have some rules for inductive inference. But there is also an assumption of his why we need all those rules. And the assumption is that the connection between premises and conclusion in inductive inference is not direct. And that's something that's turns my inquiry to a place where that directness is affirmed and is done in a way that is similar to direct realism about perception. So direct realism about perception for the viewers says that it's not like we perceive some intermediate mental states. We see objects directly. And so this will be a similar strategy, but moved from perceptual level to propositional level. And that's all I want to say about it for the moment.
So the idea is that a scientist in a particular domain can just see the cogency of an inductive inference in the same way as we directly perceive objects. One of my guiding principles is let's go to the science itself and see how that works out. And there is a phenomenon in the science that looks exactly like that. Scientists have great trouble actually articulating why this is evidence for that. They know it is.
Yes.
They have no doubt about it, right? But they have difficulty articulating exactly how it works. So look at Darwin's evolution, Darwin's origin of species. He's actually using the argument form that we would now call inference to the best explanation. But it's not until text added to the very end of the 6th edition of Origin of Species that he actually articulates and identifies the argument for. And even then, it's done in a very hesitating way. Oh, so, okay. I'm sorry. So I'm trying to be you and think more about it. So I'm worried because words like generally are very difficult for me to explicate and to articulate exactly what their import is. You're saying maybe there's a kind of a tacit, ineffable understanding that the scientists have that's filling the gap. They just kind of know. It's a bit like an expert diagnostician in medicine. It takes one look at the patient and says, "Oh, yes, you've got such and such." Or the classic example is X-ray radiographers, who, I don't know if you ever had this experience, but the X-ray goes up on the wall, and you look at it and you see patterns of light and dark. Yeah. And they take one. I had this. My son broke a bone in his hand, right? And I'm there with the doctor, and we're both looking at this, and he says, "Oh yes, there it is, right there." And I'm looking, I'm thinking, "Where? What?" It just, bang! He just knew. Anyway, all right, yeah. I don't know. I'm worried about that. The worry is, to what extent does this make cogency of scientific inference subjective, right? You just see it. You just see the inference works. I don't. Right? Now what do we do? The reason I've kept myself closely attuned to explicit propositions and relations among them is because it can be then explicitly debated, right? Steady state cosmologists, I don't think your reasoning is good because your warranting premise is false, right? That's, it can be handled explicitly. But if they say, I just feel it, right? I just know this is the right answer, and I don't, there's an impasse. But that's a problem to be solved, not an endpoint. How do you solve that?
And there is actually a lot of research on, how is this called? Yeah, I forgot the name of the field, but it's a field of research in epistemology where they argue how is it possible to be, can people have the same evidence and different conclusions and be rational or irrational? Yeah. And to a large degree, the way people answer their cases like, yeah, okay, you say, I basically know that the Earth is round, it's spherical, I basically see it, in a metaphorical sense see it. You don't, how can we agree? I think to a large degree, the answer is that one person is in some form of delusion. Either is in form of delusion or misses some material fact, basically, that person overlooks. There is some background fact that the person overlooks, or is in some form of self-deception, and that form of self-deception doesn't have to actually take place at the moment when we decide what theory to believe, because people decide whether to draw attention to evidence or not over long periods of times, and they make very, very different decisions that affect their beliefs, their methods of gathering evidence. And so there is really a lot of ways that we can answer it. But going back to how this works in science and maybe in children, I noticed that when children ask about, how do you know that this is the case? They don't even get the question. I see. What are you asking about? I had the case of a child which could recognize what brand of a given car actually is on the street and on the toys. And yeah, his answer was very often, I simply see. Or when I tried to explain inductive skepticism, Hume's argument to people, their answer, and then try to poke them, how do you know that this is the case? They react, I simply see. Metaphorically, not literally see, but in some form I see. And actually in your book, you have a little quote of Copernicus where he speaks of the experience that people who don't accept his theory and instead believe in geocentrism actually have, that there is something disharmonious. So he talks a lot about experience, and that's something also informing me. But let's move further. Another thing
I should just say,
yeah.
Can we go for maybe 10 minutes more, because I'll have to wind up here. But I just want to react with another example of what you just described. There's a thing called confirmation bias, right? If you want to believe something is the case, you see it. The dowsers, certainly, the water dowsers certainly do that. You know, the trick with water dowsing is that under almost every place where anyone might consider to do agriculture, there's a water table. And so if a dowser goes out and says, I found it real here, it doesn't really matter how we found it. They're gonna find water. But the experience for the dowser, right, is very striking. They go out, they believe what they're doing works. They come, they get this feeling in the sticks, right? And then the farmer drills the hole and there's water. So they get massive confirmation for their belief. Of course, the skeptics just say it's confirmation bias because it always, Okay, let's move on.
Yeah, another thing, maybe the last thing that I wanted to ask you is, you are rejecting norms as a way of rules as a way of justifying inductive inferences. But is normative guidance possible given the material theory of induction? Because
absolutely. It's in the book, and it's pretty simple. And it's this: if you want to infer inductively better, don't waste your time reading logic books. Learn more facts. The more you know, the more you can infer inductively. And I think, it's just go and do more science. And the more science you do and the more you know, the better you can infer. It's, I think, a very useful thing to say. And it's very simple and it's very short.
Yeah, I think we can actually in your book find many cases of little norms, like inference is warranted if and only if warranting facts are actually facts, or infer only what the evidence permits, not on the basis of some alleged simplicity, or simply base your conclusions on the evidence and in proportion to evidence. And in one way, people might react that it's trivial, like people reacted to the principle of non-contradiction as something to be beloved by saying that, yeah, but it's trivial, it doesn't get you anywhere. Maybe you have some account of this, but I think those things are in a way obvious. It's another thing whether we remember about them and whether we apply them actually. And maybe there's actually some worth in bringing those obvious norms explicitly to bear them in mind, basically.
Oh, yeah. I'm not at all bothered if someone says, well, that's an obvious truth. It's a truth. Well, no. But there's a dynamic, by the way, in philosophy that you might have noticed. And that is, when a problem is well posed, often the solution is kind of easy and obvious, right? So people say, well, that was trivial. That was an obvious answer, right? Why are we getting so excited about such an obvious answer? The point is not the answer. The point is the question. The really hard work goes into formulating the question so that it has a simple answer. I work with students all the time, and I keep telling them that you're going to have this experience. You're now looking at this inchoate mass of ideas, You try to find your way through it. After a lot of thought, months, years, you eventually find a way to simplify it down so you can pose it as a definite question that you then answer. And people will say, well, that's a kind of obvious answer. And you will want to say, yes, but it took me years to find the question.
Yes.
And that's the position you're in right now, by the way. It's going to take you really significant time to find, well, maybe you found the question. Maybe you have the question. That is exactly how do warranting facts warrant inductive inferences. Right.
Yes. And maybe we can even have some norms about forming questions, because we have something like erotetic logic, which is concerned with questions and answers. But that's a side point. I think it's a great place to wrap up. Thank you so much for appearing on discussing these things today with me. It was a great pleasure to talk to you, and thank you so much.
Well, you're very kind. I'm very pleased to talk to you, and I look forward to talking to you again. I hope we can stay in touch.
I hope also too. And thanks to everyone who was listening or watching. I hope you have had a nice time. Bye.